We're back with more examples of rationalizing denominators. So example 6, I have 8 over 3 rad 2. The rad 2 is really what's causing me an issue right now. I can't have a radical working beneath an 8. And so in this situation, since it's only the radical 2 that's causing the issue, I'll multiply the top and the bottom by this rad 2. Now this will take me to an 8 radical 2 for my numerator. And then downstairs when I look at this, a rad 2 times a rad 2 is really just a regular 2. So this becomes 3 times 2, which is 6. Before I go to the next problem, I have to always look at this and ask, do I have an opportunity to cancel or reduce? Again, with the original, sometimes kids will try to cancel because they're recognizing the 2 and the 8. You've got a free versus a jailed, so you can't cancel those. But after I've rationalized, I multiplied the top and bottom by rad 2, I've got an 8 rad 2 over 6. Both of these numbers are free, so to speak, so I'd be able to reduce those. And so I say that 2 goes into 8 4 times, 2 goes into 6 3 times, and that would take me to 4 radical 2 over 3, which is considered a stable fraction. We'll move on. Really, the only way to understand this is to do a ton of examples. So we'll go to example 7. In this one I have 9 radical 2 over 6 radical 10. In this situation, I do have an opportunity to cancel on both fronts. I can look at the freed. The 9 over 6 can be reduced. And I'm going to do that. I don't want to blindly just multiply by whatever radical I have in the bottom. I want to make sure that I'm reducing everything. So if I reduce the 9 and the 6, it could become a 3 and a 2. And then because both of these numbers are under the radical, I can reduce that fraction. The 2 over 10 reduces to a 1 over 5. Square root of 1 is 1, so I'm going to leave that alone. And down here, this would go to square root 5. So I'm reducing that to square root 1 over square root 5. Square root of 1 is 1, so I'm not going to write it because 3 times 1 is 3. And it lets me basically restart this problem. And now as I look at this, I recognize that I still have the issue of having a radical in the denominator, but it's an easy fix. I can multiply the top and the bottom by a rad 5. And this takes me to 3 rad 5 over, and just like I did in the last problem, the rad 5 times the rad 5 is just a regular 5. So this becomes 2 times 5, which is 10. And I look at this fraction, make sure I don't have any opportunities to cancel. The 3 and 10 does not reduce. The rad 5 versus the 10 is not allowed to reduce, so that would be my final example, or final step. And so that checks out. And so we'll move on. We'll call this example 8. With example 8, I've got 4 rad 6 over rad 3. And hopefully you're starting to see that I'm constantly looking for that opportunity to cancel or reduce, cancel or reduce. In this situation, the rad 6 and the rad 3 can be reduced. And so I can call that a 1, call this a 2. The square root of 1 is just 1. And so a very quick example, this can be rewritten as 4 radical 2, and I'm done. That would be 4 rad 2 over 1. There's nothing wrong with that scenario. That's a stable number. And so we'll color that one done. We'll do another example. We'll call it example 9. With example 9, we have 2 rad 3 over radical 6. As we look at that problem, once again we see that the 2 radicals do have a common factor, so we are able to cancel those. I can cancel that, call that a 1. Cancel this, call that a 2. Square root of 1 is always 1. So this would be 2 times 1, which is just 2. And on the bottom, I still have this radical 2. That is not considered a stable fraction. So I employ this technique of multiplying the top and the bottom by a rad 2. As I multiply by rad 2 on the top and the bottom, this becomes 2 radical 2 over rad 2 times rad 2 is a regular 2. I look at the answer and I have to ask myself if I have an opportunity to cancel. Because both of these 2's are outside the radical, I am permitted to cancel those, which means that my final answer should be reported as square root 2. We're going to keep moving. We'll do an example 10. With example 10, I've got 12 radical 8 over 3 radical 2. Just like problem 9, you have to ask yourself, is there an opportunity to cancel or reduce? As you look at the outside numbers, the 12 and the 3 reduce. So I'm going to call this 4 over 1. Oh, I don't put 1s. It's implied 1. I don't need it. And then when I look at the radicals, a rad 8 over rad 2 has a common factor of 2. So I could reduce this, call it square root 1. Square root of 1 is just 1, so I'm going to go ahead and just put that 1 there for a minute. And when I reduce the top, because I took a factor of 2 out of the bottom, square root of 1 gave me the 1. Take a 2 out of the top, that'd be square root 4. But the square root of 4, that's a square value. You should recognize your squares. I can break that down. And so this is really just saying I've got 4 times 2 squared under the radical. If it's 2 squared under the radical, I can bring that out as a regular 2. And of course, 4 times 2 is 8, which means this the original number simplified all the way down just to regular 8. There we have 10 examples. I'm going to do another video, do a couple more just to make sure we really understand this concept of rationalizing denominators. It's really all about canceling and getting to a point where you have a regular rational number as your denominator. This is over 1, this is over 1, this is over 1. So it satisfies that condition, and I've canceled as far and as frequently as I could.